one, we can start with this webinar series. This is the first webinar of a series of 3, and we are going to talk about 3 different topics during this webinar series, and the 3 different topics will be treated in 3 different days. The first one is today, for sure. And today we are going to talk about design for manufacturing. This is the topic of the first webinar. The topic of the second webinar will be the design to cost. And then we will close the 3rd of July with the last topic. It is related to the sustainability analysis. So it is a pleasure for me to introduce Mark Rushton from A Priori Technologies, and Mark is the person that is going to provide us with a very deep and clear insight about these 3 topics. So thank you, Mark, for joining us today. And please take the lead of this webinar. You can share your screen and you can tell us more about the first topic of today. It is called the design for manufacturing.
Thanks, Enrico. And thanks to the Enginesoft team for inviting me to share this presentation with you. So hopefully you can see my screen. There we go. So as Enrico said, this is the first in a series of 3, and this one is all around design for manufacturability. Now we call it design for profitability because it's really quantified design for manufacturability. So that's what we're going to look through. As Enrico said, my name is Mark Rushton. I'm from the product marketing team at A Priori, responsible for our design, engineering and sustainability product areas. My background is engineering design. I've spent the best part of 2 decades involved in product development, namely 3D CAD and additive manufacturing. I did start out as a design engineer and then moved into software fairly quickly after that. I've worked for 2 of the big 4 CAD software vendors, and so I know the space pretty well. Now, A Priori Technologies is the company I work for at the moment. And just to give you an idea of our mission, we're really here to help our customers create great products faster by empowering them to do more with every resource spent designing and manufacturing their products while minimizing the environmental impact. So what does that mean? Well, we've been providing manufacturers, the leading manufacturers, with insights into product should cost, and we've expanded that into manufacturability and sustainability in the more recent years. We're a global team of around 300 people, headquartered in Boston, with a European office in Belfast and in Germany. And essentially we simulate the manufacturing process and give you insights into that. Some of our customers have found huge success using our product, our platform. Danfoss initiated a corporate-wide cost down initiative, and as part of that started 3 programs, one focused on new product introduction. In a study they conducted post-implementation, they projected that new product introduction programs on average would be reduced by 20 to 30%. Alstom's story is more around their sourcing, and they implemented their own 0 RFQ process using A Priori with their suppliers to really accelerate the whole sourcing process. So real nice successes from those and many more on our website. And we really help with the top priorities in industrial manufacturing at the moment. So the big 4 that we hear a lot from our customers and are shared by consulting firms and news articles, tackling inflation and margin pressure is still a really big one. There's still a lot of uncertainty and lots of churn in the top companies. and trying to innovate to stay ahead of those changes. And that's something we can really help with. Supply chain risk, whether it's the turmoil in the kind of the Middle East and the Red Sea and all over the world, there's lots of supply chain risk and disruption happening all the time. So being able to look for other suppliers, knowing how that might affect costs, is something else we can help with as well. Something that's been around at least the last 15 years, certainly I've been hearing it all throughout my professional career, is the skills gap and the labour shortage in the manufacturing space and the design space, particularly those coming through an academic route to become a design engineer. They're very well versed in 3D CAD, but less so when it comes to manufacturable designs. So that's caused an issue with the aging workforce and the expertise retiring. There's definitely a knowledge gap that we see quite a lot. And then sustainability is something that's been around a few years now, but is adding pressure all the time. And most companies have got some sort of strategy, but when it comes to the knowledge and expertise to actually achieve those goals, that's where we see a big gap, with lots of organizations planning to really increase their investments this year. So how we help is by leveraging the investments you've already made in your digital twin. So you've probably got a 3D CAD tool, you've probably got a 3D CAD model of everything that you produce and design. And a lot of companies have done a really good job there with a product-centric digital twin. But what we add is a digital twin of the manufacturing process inside a digital twin of the manufacturing facility. And by running that manufacturing simulation through a representation of the processes and manufacturing facilities that you have, either through a supplier network or your own facilities, we can give you insights that you can't get any other way. We can give you insights into how much things should cost based on how long they take to manufacture, how manufacturable the product is likely to be based on the 3D CAD model, and also what the embodied carbon is going to be based on that manufacturing process as well. So today's session is really focusing on the design for manufacturability aspect, or DFM as it's often known. And we'll take a look at some of the DFM checks in 3D CAD and really their shortcomings. And then to quantify design for manufacturability, we're going to couple it with cost, because that's really the way you can assess DFM properly in our view. And then we'll summarize that with how a priori can help. So I don't think any webinar would be complete unless we started with some AI, some generative AI. So I thought, why not get Google's Gemini to summarize the importance of DFM for me? And I thought it did a really nice job. So I just asked it, can you briefly summarize the importance of design for manufacturability? And of course, I had to be polite and ask, please, because you never know when they're going to take over. So always good to be polite to make sure we're safe in future. And essentially, it's a really nice summary, makes the whole process of design to manufacture cheaper, faster, and smoother. So it lowers costs, speeds things up, and improves quality. And that's something that everybody wants to do in the manufacturing space. And the reason for looking at the design for manufacturability is when we're in the design phase, we can make lots of changes early on without really affecting or inducing any cost. The later we make those changes, usually when we're forced to make a change, that's when the cost of those changes actually increases. And what we decide at the design phase really is locked in throughout that product's lifetime. So, and up to 80% of the product's cost and environmental impact is determined while we're still designing it. So let's have a look at what we can do while we're in 3D CAD. So lots of 3D CAD tools have some DFM checks to make sure that designs are fit for the process that we're designing them for. So we might be able to check things like the hole depth to diameter ratio, because we don't want a long small diameter drill bit, because it's likely to break, things like that. We might want to ensure we can fold our sheet metal designs. We might want to make sure we've got constant wall thickness, or make sure holes are aligned, run thickness analysis to ensure that if we're doing injection molding, everything flows in nice and evenly. Might want to check for interference detection so that assemblies can actually be put together without fouling on each component, or doing some draft analysis or undercut analysis. But there's one thing missing in DFM, in 3D CAD when we do these checks, and a lot of these require some knowledge around the process. And also, the design engineer needs to know what checks to use for particular manufacturing processes. You also need to know how to use them in the CAD tool, so it's quite easy to overlook these. And then on top of that, the design engineer has to know what data to input to get the correct result out of the check. For example, this plastic part on the screen, I want to run a draft analysis to make sure I can get it out of the tool nice and efficiently. But what do I use? What draft angle do I need to check for? Are overhangs okay? Like, what wall thickness is acceptable? Now, finding that data to run the check is not always that easy. Often it's material specific or machine specific, could even be supplier specific, or it could be the size of the part specific, depending on how deep it is. So actually knowing what value to use can be a bit of a problem, especially if we've come through that academic route and we're early in our career design engineer. How do we find what value to use? Whatever the answer, it's going to take some time to get there. Now, on top of that, I like to think of DFM as a grey scale. It's a gradient. It's really, manufacturability is really a qualitative guide. And really, it's up to a point of not being possible to manufacture, the cost increases. So for a particular manufacturing process, the more complicated something is to manufacture, the higher the cost gets. And then there'll be a point where it just can't be manufactured by that process. But for a design to be successful to the point that we need to make sure that the point at which the component's too expensive to be produced is not reached. So we need to make sure it's viable. But design engineers rarely get visibility into cost while they're producing their design. So what that leads to is changes needing to be made when it's really too late to address them. We've already locked in too many elements. So having visibility into cost can really help us decide how manufacturable something is, rather than just using best practices and things like that. So what we want to achieve, and a lot of companies and customers tell us this, they want to be able to make decisions that are data driven. So if we can get cost, there's a lot of other factors that we need to consider while we're designing. So what material do we use? What materials do we currently buy? Because there might be some economies of scale if we use a material that we're already buying a lot of. Is the design actually suitable for the manufacturing process that we want to use? Can it be adapted in any way to suit a different process? What will the tooling cost be if we're using a process that needs tooling up front? Is the tooling going to be complex? Is it going to be expensive? And is the volume of parts that I'm needing high enough to offset the cost of that tooling? And then what about the cycle time? Is that important to me? Do I need to reduce costs by reducing the cycle time if I've got very high volume? Can it be reduced? Will it make much difference? What machine is required to manufacture the part? Do I need a really large machine, which is going to increase the cost because that machine is likely more expensive? Or can I split it up into smaller parts and add an assembly operation so I can get it on smaller, lower cost machines? And then where am I going to manufacture it? Would it be better to manufacture it locally? And what's the carbon footprint going to be? So there's a lot of decisions that you need to make as a design engineer, and deciding which one is best for you is really a trade-off between all of these considerations. So we do need data to effectively derive these decisions. So the big question is really, how do you decide? And what we found with our customers is before they become customers, the product development teams are really lacking those insights. They're reliant on jobs they've done before, a bit of intuition, some of the expertise, the experience that they've got in the company, maybe some previous records and things, but it can be very limiting. DFM checks in 3D CAD are quite limiting as well. You need a lot of data to use them effectively and how to use them effectively and interpret the results. So it can make the decision making very, very complex. And without the cost estimations up front in the design phase, again, you're lacking some of those insights. So we've got a couple of poll questions that we can hopefully launch. So the first is just to understand how people on the call today are actually doing DFM reviews. So if we could launch that question, it should pop up on your screen. So it's really good to understand how many of you actually have DFM reviews as part of the process, or whether you rely on suppliers or designers to do the DFM checking themselves. So is that poll launched, Enrico?
Engine soft marketing team.
There we
Okay.
go. Great stuff.
Thanks.
So I'll just give you a couple of minutes to answer that one today, and then we'll come back and visit those answers. So yeah, it'd be really good to understand, those of you on the call today, how are you currently checking your DFM or design for cost? So do you review it with your peers or a supplier, or do you have a cost engineering department that you look at, or some manufacturing engineers? Do you just rely on the DFM checks in 3D CAD? Do you have some specialist software like a priori that can do some DFM checking, or do you just rely on designers to do the best they can and have no formal review process? Okay, so can we see the results? Okay, great stuff. So yeah, most of you just relying on your peers or suppliers. That's usually what we find, which obviously takes up significant time, presumably. So a few of you using some specialist software, but not too many, and a fair percentage with no review at all. So second question, if we could just launch the second question, how long does that process take today? Now, if you don't have a formal review process, then you can't really say how long the process takes, but for the rest of you, if you could just answer the second question, how long is that typical feedback loop? I guess if you have no formal review process, maybe You could answer like how long has it taken if a problem has been found very late on, what kind of delay is that left? And then can we see those results?
Just a second.
Okay.
Okay.
Perfect. Yeah, that's great. So yeah, hours, days, or weeks. That's pretty much what we expect. Well, if you'd like it to be minutes, then that's probably something we can help with. And very typical what we see today when it comes to any kind of design reviews. The design engineering team will create lots of designs, lots of components, and at some point they'll be either sent to a supplier, the shop floor, maybe a value engineering or cost engineering team. And depending on who it is, they'll either churn through each one, looking at how much it's going to be, or check it for manufacturability issues. If it's a value engineering team, they'll maybe just focus on the most complex parts or the most expensive looking parts, and leave the rest to chance somewhat. However, if you do things earlier, you can have the design engineering team actually creating their own costs and getting visibility of their own costs. And that way, the most expensive complex parts can be looked at by the value engineering team or a supplier or other collaboration partner. By using our platform, you can also have sourcing see the data earlier and start to leverage that, and for analytics to look at further insights, to focus on risk reduction, or use it for fact-based negotiations with suppliers. So lots of benefits by shifting left the DFM and cost analysis. So that's some of the analytics that you can use on our platform. And the way we achieve it, we import the 3D CAD model into the Manufacturing Insights platform from a priori. And all you need to do is select a digital factory. And really what that gives you is the digital twin of your manufacturing facility, whether it's a supplier's or your in-house facilities. We run some automated analysis, which is effectively manufacturing simulation based on a specific process group. And then we give you the insights to review. And then how you decide to take action is down to your knowledge and expertise and application. And really that leads to best-in-class products, because we're giving you insights into the cost, the manufacturability, and the embodied carbon or the sustainability. So I'm just going to run a quick video. So hopefully you can hear the sound from my machine. There we go, just share the sound. Okay, so this is just a 2-minute video just so you can see how our platform works.
If you are looking to join the rapidly expanding number of leading manufacturers using a priori to improve their product profitability, sustainability, and manufacturability, you start by simply uploading your 3D CAD model into the Manufacturing Insights platform. After choosing from a list of manufacturing process groups, a digital factory, and an annual volume for production, you are ready to get insights into cost, carbon, and DFM. In seconds after a full manufacturing simulation, we get design guidance based on a combination of best practices and the specific capabilities of manufacturing facilities. This allows the design to be right the first time, accelerating your time to market, and reducing the back and forth so often required with suppliers. We can also dive deeper and look at the time and cost of each operation, as well as a full breakdown of fully burdened cost, which can be used to drive further reductions during design or leveraged for fact-based negotiations downstream. We can then start to make data-driven decisions earlier in design by comparing different scenarios, altering the design, the material, the manufacturing process, or the chosen supplier or region. We can then take this to the next level of automation by leveraging a priori's bulk analysis and upload a complete project of 3D CAD assemblies. Or go fully automated and integrate manufacturing insights into your PLM system. Everything evaluated on the Manufacturing Insights platform can be viewed from a much higher level too. Using the inbuilt analytics, we can build dashboards and reports to help us identify opportunities for innovation, applying precious resources on the most impactful areas, reducing risks and focusing efforts. Or use the data for strategic sourcing decisions. On top of all that, scenarios can be shared with key project stakeholders, enabling in-context collaboration with full traceability. Removing the need to schedule time for experts to review designs, getting more profitable, sustainable, manufacturable designs to market faster than ever before.
Okay, so hopefully that gives you a pretty good understanding of how our platform works and where it can be used. And it is a platform, it's not just a point solution. So in design, you can start to use it really early on to get a good indication and directional cost, sustainability and manufacturability. And then as soon as you've run an analysis or simulated a product or a part, it can also be leveraged by value engineering or by sourcing. So you can take the same data, look at it at a deeper level. It can also be viewed from an analytical point of view and a much higher level to see where we need to focus to look at cost reductions or identify where we've got some DFM issues. And there's also a built-in collaboration tool as well. So we've got a number of applications all tied together on that Manufacturing Insights platform. So really it brings everything together as early as the design phase, and bringing everything together really gives you that holistic view of designing for profitability, because it really helps you to understand not just where you've got potential DFM issues, but the cost of making those changes and whether it's going to make that much difference. Because you can have some DFM feedback from a tool that says, you know, you've got an undercut here, or you need a bit more draft angle, but how much does it really going to affect the overall cost? One thing we can really help with is understand how cycle time and production volumes can alter the cost as well, because if you've got very low volume but high cycle time, maybe it doesn't make that much difference. So with us being able to calculate the tooling costs and the cycle times all very precisely, you get a really good indication of what you need to focus on to reduce the cost or the carbon or the manufacturability issues in that design. We can also look at regional differences, so the regional differences of labour rates and energy costs, and we update that quarterly, so you can get a really good sense of how material costs and labour costs might affect the change of the part, the component costs. And we also, with our design guidance, we give you specific values for DFM checks. So we're not reliant on you entering a value. If you tell us that a part needs to be injection molded and it's a particular material, we'll tell you what the draft angle should be for that specific material, for the specific part, for the specific geometry in the specific machine, and even work out what clamp force is required for that injection mold machine. And then all of the data that's generated, we break down all of the processes involved to manufacture that component. You can use that should cost to drive supplier negotiations, not to kind of drive your suppliers into administration, but really to make sure that you're paying a fair price, and because you want your suppliers to be profitable, but you want to get a fair price at the same time. So you can really use that, like Alstom, to have mutually profitable results. So to summarize, really considering cost early on in the design phase is where you're going to have the most success, with it being responsible for 80% of the product cost. And DFM is really the main source of cost reductions in a lot of cases. You can save up to 50% by tackling DFM nice and early on. We also find from our customers they really have a significant reduction in engineering change orders due to manufacturability issues. If you can spot something earlier, you're going to be much faster to market. You don't want to wait until the design reaches your supplier or even the shop floor internally if it's got some manufacturing issues that are going to need some changes. And since we use a digital factory approach, it really is the ideal platform for delivering quantified design for manufacturing. So you get a really good idea of what you need to change and what sort of difference it's going to make. Okay, if you want to know more, we've got a range of manufacturing guides on our website on apriori.com, so do check that out. And if you have any questions, please feel free to drop them in the Q&A box, and we can take some of those now if you want. But just wanted to remind you of the upcoming webinars on the EngineSoft/Our Latest on the events page. So next one is next week on the 27th of June. It's all around supplier negotiation. So look at sourcing and a look at sustainability, and that's the area for the week next week. And then after that we'll be looking at design for sustainability and also balancing that with cost in a bit more detail, running through some real life examples in both of those webinars. So that's what we're taking a look at.
Yeah, Mark, only one information about the next coming webinars, and information is for all the attendees in this webinar. If you want to follow also the other two webinars, you have to subscribe to each of them, because each webinar is organized as one, and so if you want to follow also the other ones, you have to subscribe in the EngineSoft website. So if you want to follow also the other one, remember to go in the EngineSoft website and to subscribe to each of them. Thank you.
Thanks, Enrico.